Okay, so another question for you. Maybe we'll get some answers. Maybe we can think on it some more. How is Rust going to move forward in the future? We say it's really good at safety and security, but everyone else is doing safety and security in C. The standards are all written assuming you're writing C, or maybe Ada, but mainly C. So how's Rust going to move forward in that world? Well, I think hopefully we're going to get some answers. So a talk to take us up into the break. Put your hands together for Eddy Petrisor.
Sure, no problem. Okay, so first things first, I want to tell you I'm very emotional. I try picture you all naked, doesn't work. I actually tried another method. I'm so emotional, I don't remember what I tried, so please excuse me if I mumble a little bit. So I think a little bit it worked looking at some videos with my son. So thank you to my son, but yeah, sorry. Sorry for any, let's say, hiccups. So expect some snippets of C in this presentation. And a little bit of Rust. I'm a beginner in Rust, but I would like to know how many of you would consider yourself somebody who understands C? Can you have a hands up? Oh, great. How many of you would consider yourself an embedded C programmer or understand embedded C? Good, good. How about regular Rust? Would you say you, let's say, have some experience and decent understanding of it? Oh, good. And embedded Rust? Good. So it seems that my code snippets should not stumble you. So my name is Eddy Petrisor. I'm an embedded software engineer. I've worked in automotive industry for more than 10 years. I'm currently employed in NXP, formerly Freescale. And it was a different company. It's the same company, but it was bought. I'm not endorsed to come to this conference by them, but the experience there has allowed me to get a little bit of more insight. I've worked with PowerPC microcontrollers, S12Z, ARM Cortex-M. I've worked with hard real-time operating systems like AUTOSAR OS and FreeRTOS. I've worked with various C compilers, so let me tell you, there isn't one C language. There are various C compilers. Green Hills, Diab, CodeWarrior, Cosmic Compiler, ARM DS5, GCC. I have discovered Rust in 2018, and I'm still consider myself roughly a beginner. So there's something weird going around here. Okay, so what's interesting about the automotive industry is that there are long production pipelines. So, for instance, one of my former work colleagues, with which I worked in 2003, 2004, was working on the instrument cluster that is actually in my current car, which was produced in 2010. So you can imagine 5 to 10 years. It's regular. It can be even more than that. But then the industry is mature, and that means using standards and defining standards to the point that even standards are defined in C. So you might say, what's wrong with C? I can do anything in C. You can even do these stupid things, like maybe this guy is either high or is getting a rash. So I'm not quite sure, but sometimes C makes you feel like this. You can do anything you want. But we all know that C is not that portable, so there are many issues, and there are solutions. But C is valued for its speed, but so is Rust. On the other hand, Rust provides memory safety guarantees, it provides ownership concepts, we all know these kind of things. So it's a perfect match for the automotive industry, which, recognizing the faults of C, have actually devised what is called Motor Industry Software Reliability Association C, or MISRA C, which is a subset of C trying to address many of the issues which C has, just to get over all sorts of issues like buffer overflows and everything that we know from C. But On the other hand, other values, all the values of a language or a framework are important. So one value of C, in my opinion, it's simplicity. But another core value of Rust, on the other hand, is memory safety. But before we even consider that, we should think ourselves what are the hurdles to cross over. So first of all, do the standards we're complying to allow using other languages? Can we integrate nicely with C, assembly, and existing code easily? Are there known Rust problems which we might encounter and prevent us from doing our jobs? Also, we should not forget the human factor. Engineers and managers alike can oppose this shift. So we also should consider that there is a lot of legacy software. So those things should factor. So let's take them one by one. So first of all, the AUTOSAR standard. I focus on the AUTOSAR standard because I'm familiar with it. In particular, I looked at the AUTOSAR OS standard just because I'm really familiar with it. And actually, we're allowed to quote from the AUTOSAR standard. This is a legal disclaimer. So here is the first quote, which tells us that we can actually use Rust. Well, it doesn't say Rust, of course. It says that we can use other languages as long as it conforms to the C interface, in particular ANSI C interface, so, or C89. And that means that, well, you have to talk with other components in C. But there is one thing that it's really common in the automotive software ecosystem. You have static configurations. So that is our first reality check. Because the standards, just looking a little bit further in the documentation, says that any features that you do not use should not use resources. So that means if you don't use maybe memory protection, you should not have anything related to memory protection setup, and you should not have the code there. Of course, the linker can take care of that in terms of code, but maybe data, structures, and things like that should be eliminated. And this happens in practice. So you have something like this. Is this the pointer? Yeah. So you have this kind of optimizations, depending if you have 1 bit per resource, and you have less than 8 resources, you just use just a byte, or use more according to your needs. And of course, it gets complicated. It can even get more complicated than this. You have optional structure members, right? So you use a lot the preprocessor to do this kind of work. And of course, you can abuse the preprocessor. So, yeah, this is clearly C, right? This is also clearly C. But in between here, maybe this is C and this, but the rest seems to be something else. But it's actually from the Erica Enterprise. This is an open source implementation of the AUTOSAR OS standard. And this is actual production code. And there are very good and valid reasons to do this. And it mostly relates to having some sort of polymorphism of the interface depending on the configuration, because it's connected to what I was saying before, static configuration galore. So there are also other reasons like putting the code in the proper sections in memory. But yeah, this is already a problem for us. So can we emulate this kind of behavior of the preprocessor for Rust? Can we assume something like maybe let's simplify the thesis. What if our structures is behind closed doors? Maybe we can do something about that, and maybe the compiler would be smart enough. Maybe we can use macros to simulate the arrays, and we use just 1 byte for our allocation. If it's just under 8 resources, as we've seen in the previous slides. The compiler can maybe help us if we allow it to do it. And actually, this is possible because we can have attributes and which can tell you, okay, this is basically a similar implementation. Of course, it's just a toy. But before going any further, we should stop a little bit and think. Even if we can emulate the C preprocessor, what is our place in the integration chain? We should not march blindly into the dark and not remember where do we fit. So how does our C code and assembly code and Rust code interact with each other. So let's look at it from the perspective of the Rust provider. So typically, in the industry, everybody, or almost everybody, are component providers. There are very few integrators. So what happens is that you have somebody who produces some piece of code, and then they deliver that to somebody down the chain. So for instance, NXP writes something and provides it to Continental or Bosch or somebody else, and then Bosch writes something else and then integrates into a bigger piece of software and then delivers that into kind of another piece of hardware plus software, maybe to somebody like Daimler. So keep this in mind. If we are using Rust, we're only in these two parts here. So our interaction stops here with our software. So we have our Rust sources, and we have our Rust component, but we have to deliver binaries, because remember, the interface here is something that needs to be written in C. So the configuration is done by the integrator, and the linking in the integration app is also done by the integrator. So we need to have a bridge that gaps the Rust world and the C code, but that bridge is absolutely necessary to be C. And this sounds like, okay, we have our Rust code, we deliver our binaries because we cannot deliver Rust code source, and we might be tempted to say, okay, we have bindgen, so okay, we generate C code, and it matches with our Rust code, and everything is fine. But wait a moment. Our Rust code is actually static. We don't know what the configuration is. The integrator has the power, and it's the only person which decides what is actually going to be the configuration. So basically what this means is that the configuration would decide what kind of changes we need to have in the interface. And it generates a C code, and from that C code we need to generate the Rust code so it matches with our own Rust delivered code. So it looks like we need both bindgen and C bindgen to have things together. And things get complicated really, really easily. And our integrator hates us and gets tangled in a web of options and multiple configurations and variants and so on, and say, oh, next time I'm not going to work with these guys. But maybe we should stop and take it easy. Breathe in. Maybe there is something else which is simpler. Maybe we're optimizing way too early. So let's focus on the easy, absolute musts. So first of all, can we do linking? Can we do interop with C correctly? And think what we should avoid in our interaction with the C code. So first of all, linker files. Yeah, we know this, it's possible. So let's assume that we wrote our Rust, our implementation of the AUTOSAR OS in Rust. And we want to put that text code into a tightly coupled memory because it will be fast and so on, and the data, it will be in some ECC RAM. So this is possible. We can use, we deliver our libraries and we select the sections that we want and we put them in a special section, and that's it. We can protect our code from reads and writes, and we put it in execute mode, or maybe put it in flash and so on. So that's nice. How about interop? So it's fine. We have that too. We have no mangle, which assures that our symbols, as they were written in source code, will be the same name in the object files. So that's fine. Of course, we might need to add some attributes allowing some non-standard or non-rustic naming, but that should be fine. How about structures and data types? That should be also possible. We have wrapper C. And, well, it seems like we're on a good path. So we should just keep in mind that there are things that we need to avoid. This is just a part of the official documentation. But other than that, well, it seems like we're fine. If we forget about the configuration issue we were talking before. But let me tell you a little story. It's not about Rust. It's strictly about C. And in particular, is just one C compiler. And there is this piece of software that was supposed to provide communication between an M core and an A core. M core was running on real-time operating system, and the A core was running Linux, and the communication was done over a shared memory. So the idea is that right after the software was delivered, the customer complained that they were not seeing the right things in the structures. In the shared memory, there is no serialization in that case. And they were putting, for performance reasons, plain structures. And it turns out the culprit was actually these dreaded things and obvious optimization for somebody working in the embedded state called short enums. Some of you, judging by the reaction, know what this is. So basically, it means that you tell the compiler, well, use a few bytes as possible to represent this enum, and you should choose between signed and unsigned types according to what values you have in the enum. And this is present in GCC. It's present also in proprietary compilers. But well, I don't know, I'm not actually allowed. The legal disclaimer does not allow me to quote the documentation. I was about to put it. Actually, I'm not even allowed to quote the disclaimer, which interdicts me, forbids me to to quote the actual documentation. But the key point here is that there are, as I said at the beginning, there isn't one C language. I've seen in one presentation, I searched for the exact presentation, but I couldn't find it, that languages are a myth. There is no such thing as a programming languages. There are different implementations with various differences between them, and they might be compatible or not. And you try to make it work. And once you port from one compiler to the next, you understand that there is truth in this idea. But there are differences. So for instance, in WindRiver Diab, there is this thing called minus minus enum is small, which chooses between signed types, which can represent your enum. But other compilers do not have this. GCC has either signed or unsigned, preferring, of course, signed types. Green Hills also has a similar thing. So you can remember that you can you should take from this that there are differences which can influence what is the layout of data in memory. So for instance, alignment. I haven't found any restriction in the standard which would forbid this layout in memory for a structure which says this field here, X, should be aligned. I've seen that it says, okay, it should be aligned to the size, but nowhere in the specification, maybe I haven't found it, but somebody can contradict me, but nobody was able to point me to a place which say, you must use the first aligned address. I haven't found it. Maybe I'm wrong. Please tell me if I'm wrong. And this is, the point is that this is undefined behavior. It's, according to the standard, technically correct. It's aligned, but it's undefined behavior. So what about the interesting other compilers which provide all sorts of undefined behavior? Take this in. So this is WindRiver Diab. It provides a maximum alignment for the members in a structure, but it also says we should have a minimum alignment for the structure itself. So you have this wonderful padding here, right, of bytes. And if you change one value here, like the maximum member align, you get a different layout. So you have just 4 bytes of alignment, and you have a gap here. So this is undefined behavior. Right, nice. And if we want to interop with these kind of things, well, we should have a way to provide that kind of interop. Then we should think, what are the known Rust problems? Some might say, oh, Rust is perfect. There is nothing like Rust. I agree that Rust is very good. So after all, Rust says it guarantees data race-free code, thread-safe, multi-core stability, even for microcontrollers, provided you use an operating system or standard library, of course, or if you have a single-core microcontroller, and if you use some domain-specific language to specify your mutexes, right, to implement your mutexes, right? There is some limitation. So it seems there's still some uncovered use cases. There is some, and this is important because there are going to be more and more SoCs with this kind of configuration, where you have multi-core. You have maybe an M4 core and an M0 core, and maybe they want to communicate. Or you have something like this microcontroller, which has an A5 core and an M4 core. And this is actually very similar to the microcontroller where the communication issue that I was talking about with small enums was happening. It's very similar to this. Or have something more complex, like a complex of 4 A53 cores and a Cortex-M core. These are chips which already exist on the market. So it seems that solution for Rust work all the time, 80% of the time. Right? So what works almost always? So first of all, packed representation. As you know, or maybe you don't know, but if you don't know, let me tell you, it cannot be applied to enums. We cannot generate those short enums that I was talking about previously. Also, packed doesn't allow packing to other values like 2 bytes. You just align to 1 byte. And you will say, okay, then we should use a line. But that also has a limitation. You can only go up with the values of a line. You cannot align to 2 bytes U32 value. You cannot do it. You just cannot do it. So there seems to be missing bits and pieces. So first of all, short enum. It would be nice if we have it. Maybe it would be nice if we have pack different than 1, or maybe you could combine pack and align. So what about other missing pieces? Since we were talking about that C interface and the generation, in many cases, the configuration makes sense to define a variable. No functions, but just a variable or an array or something. And it would be really nice to have the symbol in the C code, in the object-generated C code, that's the actual configuration, and access it from Rust without having to use pointers and things like that. You just access it directly. So maybe you have something like a foreign symbols interface. Another thing to keep in mind, defines are not the same thing as consts. Defines are simply replacing this bit of text with this bit of text. That's what the preprocessor does. Const is different. It is somewhere in memory, there is a location where this value is held. And this actually means that you cannot have some complex preprocessor equivalent code like this one. Can you spot what the problem is besides the multiple inclusion of the header file, which is actually specified in the standard? Yeah, it's valid. And the reason is the following. You specify first, now we're starting a section of memory where we want to put the following symbols, and we finish the symbols that we want to put in that section, and return to the default one. And actually, the memmap here contains a pragma section, whatever, depending on the compiler. It says, OK, start the section, and this is stop the section, and returns to the default. So maybe some of these issues are already resolved in nightly, but we shouldn't be satisfied with nightly. Just to quote somebody, damn it, everything requires nightly. Nightly is not appropriate for production. And basically, this goes into the human factor section. Let's first talk about engineers. So, by the way, do you know what's the resemblance between engineers and dogs? They have a very intelligent look in their eyes, but they cannot express themselves. But sometimes they are very, very, very good at expressing no. Like, no, we don't need Rust. Or, no, this is crap. Or, no, this is way too complex than what we need. And actually, they might be right. They might be onto something. This is a hello world. Actually, no. This is a hello world. I grayed out this one. This is actually the hello world with regular Rust, with standard library. And the rest is embedded hello world, right? So this is complex. Of course, embedded C is also complex compared to regular C or with C on top of an operating system. But you can understand when somebody says Rust is hard, and embedded Rust is equally harder than embedded C. So you can imagine then, if we talk to our managers or our managers, we need to convince them. And they need to be aware of this kind of change that we want to make. There are known issues, and there are, as I said, mistrust C, and there is a whole, let's say, ecosystem that tries to address all the issues, but there is an expectation. So on the other hand, we should not say, okay, Rust promises X, and then we're covered. No, we should not overpromise, because if you overpromise that Rust will be a panacea, and then it doesn't deliver because people don't like it or cannot adapt, or it's way too slow to onboard, then we have a problem. Somebody will say, okay, Rust experiment was a failure. So there is even an objective criticism that can be made. The compiler is not ISO 26262 certified. And if we talk about other industries like the avionics, there are other standards which are concerned with safety, as in person safety, right? And another problem is that monoculture and open source is seen as a risk. Management and enterprise corporate environments can be skeptical of community-driven projects, unless they're familiar with open source, or if they can influence it, or the monocultures is theirs, right? So how about legacy software? Maybe many of you have touched legacy software, and sometimes it feels like this. Can you spot? There are two people in here. There's one, and there is another one here. But yeah, keep in mind that there are legacy software, even if it looks ugly, it means typically it's thoroughly tested. So for instance, at some point in the past, I was asked to revalidate a release on a different version of the compiler than it was validated when it was released. And that release was done 7 years prior to the moment when I was asked to revalidate. And that means that there was 7 years between our release of software until they were considered to go into production with that code. And they realized that they need a new version of the compiler for production use. So yeah, take this into account. It's not easy. So what conclusions can you draw from this? If we go over some of the stumble blocks Rust could be used, there are workarounds and solutions for some of the issues, but for other things like the issues caused by the preprocessor, there are gaps which we need to fill. But as a person wanting to work on it, or work on Rust, you should go slow, you should experiment, you should be honest and learn and teach others about the failure and successes. You should try to improve the software, the project, and the entire ecosystem, right? And don't try to rewrite everything. And by the way, avoid second system syndrome. If you don't know what it is, it's just trying to make everything perfect and put all the features and never deliver. That's second syndrome system. Avoid it. So what can the Rust community do? Well, it's, I would say, quite simple. Stabilization. It's really important. And we know that embedded Rust wouldn't have been possible without no STD. I don't mean the diseases. I mean no standard. We need to stabilize the assembly interface, or maybe we need to provide. Oh, and by the way, I'm not talking just ARM. ARM is just a piece of the story. We need to have more. And in my view, we need to have samples, hopefully less creepy than these samples, right? I mean samples of how to implement standard-like types like mutexes and RC based on hardware which is on the SoC. Yeah, sure, this is not possibly most likely visible, but most SoCs which are multi-core include some hardware which allows hardware locking. And this, if we have some examples providing, okay, this is how you should do it, then it will be fine. There is no formal specification of the language. So people would consider that there is no choice. But fortunately for us, and this is good news, there is one alternative Rust compiler, Mutaba Rust compiler. And the best news about this is that it's actually generating GCC C11 compatible code. So it's taking Rust code, which is assumed to be borrow checked, and it generates C code. And if we generate C89 instead of C11, then maybe we solved our issue. So that's about it. Thank you, and I'm waiting for questions.